Good afternoon, everyone. Today's lecture is on quick response manufacturing and lean, and we're going to discuss the differences and strategies and approaches that companies are using from a management perspective to accomplish the goals of this course, okay? The first question you have to ask yourself fundamentally is, how do you win business? Well, oftentimes it's a bid process. So you want to think about things like price, often a key factor, lead time, quality, total cost of ownership, and customer service. Customer calls and needs something. Is price going to be what they drive on? No. They first think, do you match my lead time requirement? And then they look to price for many products. So win probability comes down to, do you have a good lead time? Do you have a good price? So this begs the question of being a quick vendor, which is how much do we want to spend on capacity and inventory? Do we want to be a quick vendor or do we want to be a low-cost vendor? And there's a fundamental conflict between these goals. How can I be quick? I can store large inventories, right? That way customer calls, I can send it out immediately. Or I can have extra capacity, so that customers wait less time before I'm able to send out their product. So what is your strategy? Do you want to be the lowest cost producer, the highest quality, the quickest lead time, or the best service? And really, I think companies need to pick one and make that their primary one. If you try to do everything, it's impossible. You can't be both the cheapest and the fastest with the best customer service. No such beast exists, right, for many products. So focusing on one area is good. Lead time increases with utilization, and we all know this, that the more you're utilized, the longer the lead time because of queuing theory, right? At 100% utilized, your lead time goes to infinity eventually. It's an asymptote. Now, companies talk often about being over 100% utilized. That just means they're running overtime or have underestimated their true capacity. So companies can, lead time is typically decreased by inventory investment or effectively allocating the inventory you have. And there are many times where you want to put the inventory in raw materials instead of finished goods because you may have a lot of finished goods but few raw materials, and we'll talk about that. Lead time can be decreased with overtime and outsourcing, but these are very complex objectives. In any company, we have issues of volume, mix, and margin. And these characteristics fundamentally define the firm and the management policy they should pursue. So if you're in an extremely low margin industry and there's no way to change it, are you going to care about quick response to customers? Not really, because you're making 1% profit margin off selling this commodity, right? What you're going to care about is just selling all that you can, keeping your machines busy. If you're making a 40% profit margin, what do you care about then? Making your customers happy, right? 40% profit margin, you can have spare capacity, you can have extra people. You're printing money, okay? And so what we're going to talk about today is the high margin, high mix, a lot of different product types, low volume industry, okay? Specialized products. And that's where this idea of quick response manufacturing is intended. So management theory has taught us different lessons throughout history. Man, that sounds goofy, but it's true. Lean teaches you what? Eliminate waste. Six Sigma teaches you focus on quality and process. Theory of constraints teaches you there's always a bottleneck and schedule appropriately around the bottleneck. ISO 9000 teaches you document what you do. And you could go on the mix. Today, many industries, these manufacturing strategies don't really apply all that well. And this is true especially in high-mix, low-volume manufacturing. Think custom parts for the chemical and oil industry, precision parts, machine tools. All the things where there's growth in U.S. manufacturing, a lot of them fall into this high-volume, low-volume mix. Every customer's getting a slightly different product. And this leads us to the concept of part proliferation. I may have 10 raw castings that are turned into 1,000 different types of whatever, precision milled, valves, pumps, whatever. And so my 10 raw materials, each can be turned into 10 product types. Each product type can have 20 threadings and 5 different test plans. So each time I can look at a product and say, well, that's product A tested with method B, which is different than product A tested with method C. Okay? So at the end of the day, can I really hold finished goods in this environment? No, but I can hold raw material. And oftentimes you have the 80-20 rule doesn't really apply. You don't really have commonality. So where should you store your inventory in such systems? Clearly you want to look at raw material instead of finished goods. So let's say I'm producing 10 parts per week. The lead time of the raw materials is 5 weeks exponential, 40 hours of touch time in manufacturing. And then I have the same thing with a massive number of parts coming from those raw materials. Question is, how much inventory, how much spare capacity? I can't hold finished goods, right? Because there are too many potential products. What can I hold? I can hold raw material inventory, eliminate that lead time from the supplier, my supplier, and then I can have extra capacity on hand to cut the manufacturing time. And any of you interested in this lecture, Google Quick Response Manufacturing, and it'll take you to Dr. Raja Sura's website at University of Wisconsin. I think the guy is an absolute genius. He's marketed these simple concepts and made a lot of money. And it's brilliant. Quick response manufacturing. The only thing's important to look at is lead time. Think about everything in terms of time. Focus on the enterprise solution. Figure out where in the process, close the door, you're losing time. And then address those issues. Spare capacity is okay. As a matter of fact, quick response manufacturing says 60% utilization. So capacity is not an issue. We're going to have extra machines, extra people at the ready to aggressively attack the marketplace. How can I have extra capacity? What do I have to have in order to be able to do that neat trick? Can I have a 1% profit margin? No. What do I need to be making per item? 40, 50%. At which point you can say, yeah, I can buy another machine tool, or I can have some people, or I can run overtime. So this doesn't apply in other industries. Rethink the manufacturing process and equipment. Try to simplify it in terms of product proliferation. Quick response manufacturing studies everything based on both cost and time. Lean is so heavily cost focused that if you do lean, you're always looking for what? Waste. It's very hard to convince somebody that spare capacity is not waste, right? Somebody sees this machine sitting idle. What's management going to say? What's the reaction? I see you sitting idle by a machine. What is management's natural reaction?
Get to work.
Get to work. Why is this machine not working? What is that machine doing for you at that point when it's idle? Fundamentally, it's giving you space that you could have sold to customers. Okay? So an idle machine just represents we didn't sell the space, but we had it available. We gambled and we lost. But the next day, maybe the machine's running because it was idle, because it existed and wasn't idle. Does everybody kind of get that? Okay. So we want to study time and cost. We want to monitor both the touch time, the value-added time, as well as the elapsed time from the start of the process. Elapsed time can be a lot longer than value-added time. Think about waiting for ordering parts, engineering, waiting in the queue, and you want to report and look at these items. Some key ideas from quick response manufacturing. Operate at less than 80% utilization. Totally opposite of every thinking previous. Focus on lead time. Do not focus on due dates. Focus on lead time. Here's a question. You miss a due date. Is that a measure of your manufacturing performance? Only if manufacturing made the mistake. What's it really a measure of? How well you set your due date. Lead time measures manufacturing. Due date performance measures how good do you set your due date. Right? Does everybody get the difference? You control when you told the customer it was due, but the key thing is how long in the future is that expected, okay? Employ cellular manufacturing. Employ cells with limited inventory, and I'll talk about that. Another big thing, hold inventory in undifferentiated states. Look for opportunities to pool inventory. Motivate suppliers to have small lot sizes. Cut through functional boundaries for quick response manufacturing. So they're really into cellular, and we'll talk about that in 2 lectures. Quick response manufacturing is a cellular approach. Make sure that you delay differentiating the product as long as possible. And mix make to order and make to stock. So QRM is effective in industries with high margin, high mix, low volume. If you have a high margin, your goal should be to attract business as much as feasible without lowering your price. How do you do that? Good customer service, short lead times, good quality. Okay? And this customer focus. Time is money. Lead times have direct and hidden cost. High volume, low mix manufacturers, the touch time is usually much less than 5% of the total lead time. You're waiting for parts, you're waiting for machines, etc. Another thing quick response manufacturing focuses on is team. Everything should be product focused. And so your product team, according to them, let's say I'm making aircraft engine. Well, aircraft engine is a bad example. Let's say I'm making wells for the oil industry. And I have a 12-inch well and an 8-inch well. And I don't know if those are real sizes or not. Well, in QRM, you would divide up all your products and you would say, these guys handle 12-inch wells. Okay? And so the sales team that does 12-inch wells would interact with the manufacturing team, and everybody is involved in 12-inch wells. You combine that with cellular, which basically is a product-focused layout. So I'd make a cell for 12-inch, and it would have a lathe, a mill, and a drill. And then I'd have a 10-inch cell, lathe, mill, drill, and an 8-inch cell, lathe, mill, drill. And these guys would always do 12-inch. Their manager would be the 12-inch supervisor. And he would report to the 12-inch plant manager, who would then report to the 12-inch director. See what I'm saying? Don't have a factory that does 1,000 products. Have a factory that have 4 little factories inside the big factory. Okay? So that everybody knows that they're responsible for 12-inch and doesn't get confused with the 10-inch workload. This is expensive because I might be able to do a similar factory, which was lathe, lathe, drill, 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 mill, mill, cut out a lathe and a mill, still have enough capacity, and then just route the material like this. But then things can get lost. Whereas this is much simpler because these guys are always doing 12-inch. This is cell and job shop. We'll talk about that next lecture. Also, their support staff should be aligned to the product. So purchasing and engineering would be product aligned in quick response manufacturing. So the 12-inch team would have a 12-inch engineer, they'd have a 12-inch buyer, they would have a 12-inch expediter, they would all kind of report to each other. Why? Because they want the people who do 12-inch to all know each other and work well together. Now, the key tool to doing QRM is the concept of value stream mapping. And when you make a value stream map, you really are looking at time. And so here's a value stream map from Wikipedia. And it takes us 5 days to get our product from our supplier. And then we spend 2 hours, 5 days waiting for the mill, 2 minutes milling, 10 days waiting for welding, 4 minutes milling, welding, 15 days waiting for painting, 1 minute painting, 6 days waiting for assembly, and that's our total time. Obviously, what does this crazy one up here show if you can see it on the small screen? All of our time is spent non-value added. Product has 68 days, of which 15 minutes is actually working on the product. This is very hard to see unless if you start thinking in terms of time, not money, not quantity. Does everybody see the philosophy behind QRM? Value stream mapping is a tool to visually display lead times. The goal is to show both the material and information flow in the system and to then develop an as-is and to-be state to do what? What are we trying to save? You trying to save money? Somebody say the word, please. What are we trying to save in a value stream mapping exercise?
Time.
Time. Lead time, right? And it's a powerful tool to show management how to improve business. Examining the problem in terms of lead time can find bottlenecks. Is it engineering and procurement? And often these have more delays than the manufacturing itself and more of an effect on lead time. This is why QRM says what? Align via product, so that you make purchasing responsible for the fact that it takes 6 months to get a 12-inch product. Once the bottlenecks are determined, you can find solutions to fix them. 5 whys is my favorite method. We've talked about that before. Ask why 5 times. Why does purchasing take so long? Well, they don't, the supplier takes that long. Why is that? And so on. What does your customer value? Is it quality? Is it cost? Is it service? Is it lead time? Answer this question and you'll be able to pick your management strategy. But lean is not always the right approach. So last slide, and know this summary for this class. Lean, continuous improvement to reduce waste, time, defect, overproduction, inventory. 6 Sigma quality, process-based, just-in-time inventory reduction, process control. Theory of constraints, finding bottlenecks and other items. QRM focusing on lead time. All of these management approaches, like team approaches, focus on employee participation, remove barriers between groups, develop clear communication of ideas. Teams are always good in management theory textbooks. There are advantages of teams. It allows you to fix problems across boundaries, gain feedback, how to solve problems. There are other times where team-based concepts don't work. One problem with teams is they reduce people's focus on their task at hand. Apple is famous for not telling their employees what they're doing on a team. They're very compartmentalized. What benefit does that give them? Employee doesn't care about the overall picture, they just care about what? Their part in the puzzle. Teams also are time-consuming, and they generate potential conflicts between groups because purchasing may get in a turf war with engineering, or engineering may get in a turf war with operations. because they're working too closely. Lean, eliminate transportation, inventory, motion, waiting, overproduction, defect, waste. And you could argue that none of those wastes involve reducing lead time, do they? See the problem with lean? And I know there are some lean people that say reduce inventory to the minimum amount necessary. And that would encompass lead time. And so lean can solve every problem. But it's really trying to bend a strategy that's cost reduction to a strategy that's service improvement. And so you'd be best off with a service improvement philosophy. Any solution is okay under lean, and any of these others: process improvement, design modification, quality improvement, layout changes, inventory policy. Six Sigma has the famous design, measure, analyze, improve, control, domaic process, which is a good process. Six Sigma has many different tools, and etc. Theory of constraints, I'll let you guys read these slides, and we're trying to keep this lecture short, but developed basically to identify the bottleneck and pace your equipment around it to control inventory on the shop floor. All of these management philosophies have insight. Fundamentally, QRM versus lean, lead time focused versus cost focused. And let's spend a few minutes and let's consider the PIC answers to these questions. And obviously, process improvement can fix anything. Design changes can fix anything. Quality improvement can fix anything. So let's focus on PIC. Long lead time for customers. What's the magic solution for long lead time? We talked about two. It's either inventory or capacity, right? You add inventory, you cut lead time. High inventory levels. Obviously, the PIC solution would be to reduce the inventory levels and see if they were valuable, right? In any of the models discussed in the course. High cost and low margin versus your competitors. Should you be thinking QRM or lean? You have a high cost, low margin compared to your competitors. So you have a 5% margin, your competitors at 20%. Lean, right? You're trying to drive the cost down, margin up. QRM, what are you trying to do? You're trying to service your customer better, lower some margin, increase sales. If you have a 40% margin, you take it down to 35%, you double your sales, you're making a ton of money. Late orders. That could be either your lead times are too long, but it's also how you set your orders, right? Lean and Six Sigma are skills that are in demand in industry. The department offers a 3-hour undergraduate course in Lean and Six Sigma during the summer. They're really good. Dr. Underdown teaches them. The IIE chapter has Lean and Six Sigma training, which are good. Have any of you taken those? Yeah?
Six Sigma. Lean is on 22nd.
Okay, how was Six Sigma? Are you taking the Lean?
It's on 22nd September. No,
It's not.
Next Friday.
Yeah, next Friday.
Okay.
Next Friday.
And these will give you a better introduction in a sort of different learning format, and you can write that you've had the courses. Let me conclude with this. Industrial engineers make powerful statements, okay? And one of the statements that the QRM allows you to say is things like, if you give me $5 million to add to inventory, I can cut lead time from 90 days to 30 days. And you can increase your sales. And those are the questions that you want to, those are the type of projects you want to work on. So if you want, go look up QRM. It's an interesting site. The test questions are going to be, what does QRM focus on? What are some of the approaches for QRM? It's team-based, lead time-based, cross-functional teams, focused on lead time, not due date, things like that. Anyways, have a great evening, everybody.